Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In this specific discussion, we're going to look at the concept of the sine and the cosine of theta, or rather x, an arbitrary value for the angle, either theta or x. But for this case, we're going to use the value of x as I've given it above. And these are going to assist us, of course, try to define the value for the cosine and the sine of theta, which are two basic trigonometric ratios. And from our first discussion, we are given some ratios for the sine and the cosine of theta, and we established a relationship between these three basic trigonometric functions of the sine, the cosine, and the tangent of theta, whereby we say that we can be able to uh, uh, define the tangent of theta as the ratio between the sine and the cosine of theta from that specific angle in right, or rather the angle in standard position, which we had defined in our previous video. So in this case, I'm going to use one of the illustrations which is going to assist us, of course, define the same. In our last case, we had seen just a general illustration for the angle in standard position. But for now, we are going to restrict ourselves to a specific set of what we refer to as a unit circle. And in this case, for the reference for the concept of a unit, then therefore we're going to refer to as a quantity which is referring to one. So therefore, the illustration that I'm going to give you on the board is going to be a representation of a Cartesian coordinate system, which is in two dimensions, of course, where we're going to consider the four sides for positive x, y, and of course, positive x square directions in that specific respect. So therefore, I'm going to have this one as an illustration for that, and we're going to have this one having a radius of 1 unit along the x-axis and 1 unit along the positive x-axis, and this is going to be the center denoted as O, and therefore this is going to have a stretch of a -1 and -1 along the negative x and y axis respectively. So in this case, we're going to assign what we refer to as coordinates. And we had said that coordinates basically are going to be a set of 2 points which are going to represent a point along this specific circle, or the points on the Cartesian coordinates. And therefore, we can be able to represent this at this particular point, of course, for the positive one, we can be able to assign the coordinates for this point as a stretch of 1 unit in the x direction as 0 along the y, and other respective coordinates are going to follow in that particular order, where we're going to have this one as -1 as 0 given as such, and then we are going to have this one given as 0 straight along the x-axis and +1 along the y-axis given as such. So in a unit circle, of course, of a radius that is going to be represented as r, in this case, the stretch for r is going to be equivalent to 1, which basically is going to form our radius. And therefore, we said that we can be able to define this as specific coordinates of endpoint generally as, perhaps if I give the coordinates of a point r, then we can be able to give them as r into x, y, given as such. And these are going to represent the two basic values for the sine and the cosine of theta respectively. So therefore, these are going to directly translate to the sine and the cosine of theta, or cosine of x in our case, which of course we're going to contrast it with this specific x. So in that case, I might be, of course, I've already used it here, I might be able to change this one in order to create the difference between this one and the x-axis. So therefore, these are going to represent the sine of theta and the cosine of theta in that specific order for the x and y axis, representing that one. So we have said that the radius is going to be represented using a value of 1. And by Pythagoras theorem, that therefore we have said that we can be able to represent the relationship between this radius, the stretch in x and y axis from our first discussion, whereby we're going to see that the relationship between the y and the x can be represented using the square of x and the square of y, which basically are going to give us a product, or rather a sum of the square of the radius given as such. Since we have said that this particular value for the radius is going to be represented as a unit, we can be able to give this one in terms of the sine and the cosine of theta for that specific case for x and y, this specific point over r, by substituting them for the square of the sine of theta and the square of the cosine of theta given as such. So therefore, this is going to give us what we refer to as an identity, which is going to give a relationship between these specific coordinates and the radius of that particular angle that I've given. And therefore, we are going to see that the cosine in the first coordinate of the terminal point on the unit circle for an arc of length theta is going to be given from the ratios that are given. And of course, that is using the acronym that we had given for the sine, the cosine, and the tan of theta, by having these ratios represented as opposite over the hypotenuse, adjacent over the hypotenuse, and opposite over the adjacent, whereby the adjacent is going to represent the stretch in the x-axis and the hypotenuse is going to represent r, whereby the opposite is going to be the change in y relative to this specific angle. So therefore, we can be able to use that one to trace various trigonometric functions of that specific representation that I've given on the board. So the stretching angle, as I said in our first case, is going to be given in terms of a positive value. And in this case, we had said that that is going to be read along the counter clockwise position from this particular side along the x-axis. So the terminal point is going to rise along the negative, or rather the counterclockwise direction, in order to give a stretch of an angle theta that I've given from above. Now from this specific unit circle, then therefore along various points, we're going to see that there are various trigonometric functions which are going to be defined, and that is for the cosine, the tan, and the sine of theta, whereby we're going to see that these are going to form a fundamental trigonometric ratios which are going to be established along the four quadrants for the first, the second, and the third, and fourth. So in this case, if the stretch of an angle starts at this specific point of the origin along the x-axis, and the terminal point is going to rise along this one. So a full angle is going to be, a full circle is going to be consisting of 2 pi radians. All of this is equivalent to 360 degrees. So a stretch between 0 and 360 degrees along these ones is going to run along in these 4 specific quadrants for the first, the second, the third, and the fourth respectively. Now we're going to see that there is a particular trend that is going to be assumed for the various values for these specific ratios for the sine, the cosine, and the tan of theta, in a sense of either the positive value or the negative value. So therefore, I'm going to give a representation which is going to give various values for angles, either positive or negative, in these 4 quadrants, whereby we're going to have this one represented as a circle along the y and x for these 4 trigonometric ratios. So in this case, I've said this is a -1, -1, and 1 along these various axes that I've given, and this is going to represent the origin. So therefore, we're going to have another acronym that I'm going to give, which basically is going to be represented as acts. So this acts is going to assist us know which specific ratio is positive at what quadrant. So for the first, if we name the quadrants in order of that counterclockwise direction, then therefore I'm going to have the first, second, third, and fourth. So for the first quadrant, all the trigonometric ratios are going to be positive. The second one, the sine of those trigonometric functions are going to be positive. The third quadrant, the tangent of those trigonometric functions are going to be positive. And the last one, the cosine, is going to be positive. So this is going to be, for easier remembrance, we are going to have this one acronym read in the clockwise direction in the form of acts, and then we're going to have to memorize that one as one of the strategies of trying to define those trigonometric functions in the 4 quadrants which I've given above. So that is going to form our last bit of our discussion on these 2 basic trigonometric functions. But they have given us a general view on how we can be able to name others in case we come across them. So catch us in our next videos. We're going to look at various aspects of trigonometric ratios and the various applications which are going to be accompanying this specific range of angles for the 3 basic trigonometric values, or rather trigonometric ratios. So that is it for now, guys. Bye. God bless you.